Okay, so this is Unit 5, Lesson 1, Modeling Polynomials. At the end of this lesson, I'm going to do an exit slip that you're going to need to have access to the internet. So just make sure you have that available. So by the end of this lesson, what you're going to do is be able to identify a polynomial and be able to classify it. So first of all, we need to review some of the terminology. Variables are letters that represent an unknown value. Whole numbers are the set of numbers that start with a 0, and they go 0, 1, 2, 3, 4. There are no decimals, there are no fractions, they're just whole numbers. Real numbers is a number that is either a rational number, so those repeating decimals, those terminating decimals, or it's an irrational, so those non-repeating, non-terminating decimal. Now, another way that you can represent a real number is that any number that you can find on your calculator is a real number. And numerical coefficient is the number by which the variable is multiplied. So I'll give you an example. We've talked about this in class a lot. So if I have 2n, this is my variable. Okay, so that's my variable. This would be my numerical coefficient. So since this is 2 times n, so 2 times some number, that's what makes this the numerical coefficient. So in your class notes, so you're filling out your workbook as I'm working through this lesson. What is a polynomial? So a polynomial, it's an algebraic expression. Really important that you know it's an expression. There is no equal sign. Okay, so they're all expressions. It contains one term or the sum of terms. And we're going to talk about what a term is. The exponents of the variables, so we have variables, and those exponents have to be whole numbers. Okay, they have to be 0, 1, 2, 3, 4. So here we go. What's a term? Because we know that a polynomial is an expression that contains one term or the sum of terms. So what is a term? Well, a term is when a variable or variables is multiplied by a real number, that numerical coefficient again. So here's my numerical coefficient. Here is my variable. My exponents are all whole numbers, because remember that invisible number, remember that identity law that we talked about in Unit 2. Our exponent here is 1, so that makes that a term. Here we have a numerical coefficient of 3. We have two variables now. We have an x and a y. Here we have a numerical coefficient of -2. We have an x, we have an x, we have a y, we have z. We're multiply them all together. We don't see any addition or subtraction signs. This is a negative sign. That's not a subtraction sign. So all this put together is called a term. And our numerical coefficient can be a fraction, because remember, our numerical coefficient can be real numbers. Just our variables, the exponents of our variables have to be whole numbers. So a term can also be a number with no variable. So 1/2, 10, 100, or -100, 0. And whenever a term doesn't have a variable, we call it the constant term. Okay? So no variables, it's called a constant term. And then we're going to discuss what type of terms with variables, what they're called, coming up in the lesson. Remember the numerical coefficient of the terms b, x, y. So remember, when we don't have a number in front, and since we know our numerical coefficient is multiplied by the variable, if I multiply by 1, it's still going to be that number. If I multiply x times y by 1, it's still going to be x times y. So we don't put the 1 in, because remember, mathematicians are lazy. So we don't put the 1 in, but we assume it's there. So no numerical coefficient, we know that there is a number 1 there. Okay? So a polynomial cannot have terms that have the following. So a polynomial cannot have terms where there's a variable in the denominator. So see how there we have a fraction, and since the variable is in the denominator in that bottom part of the fraction, this makes it not a polynomial. Okay? You cannot have a negative exponent. Remember, all of our exponents have to be 0, 1, 2, 3. So as soon as you see a negative exponent, it is not a polynomial. And we cannot have a square root of a variable. Okay, and you're going to learn why in Math 10 Common, but just know for grade 9 math that you can't take the square root of a variable. You can take the square root of a number, and as long as that variable is outside the square root, this is a polynomial, so this is good. But as soon as you take the square root of the variable, this is not a polynomial. And you're going to learn more about those in Math 10 Common as well. Okay, so just to review, no variables in the denominator, no negative exponents, and the variable cannot be square rooted. Okay? So let's go up here and let's just talk about what's a polynomial and what's not a polynomial. So maybe pause, work in pencil so that you can erase just in case. And then try it yourself using what we just learned, and then press play and then see how many you get right, and I'll discuss why each of them is a polynomial or not. Okay, so welcome back. So this one right here is a polynomial, and the reason why it's a polynomial is because this is like saying square root of 2 times y. Okay, so that's just a nice shortened way of writing what I just wrote down. So since the variable is not part of the square root, it is a polynomial. Okay, so x minus 2 is a polynomial. We have a constant term. We have a constant term here, and then we have another term. This one is a polynomial. Remember, the rule is that in a fraction, as long as this is not a variable, and 2 is not a variable, so therefore that is a polynomial. So this one is not a polynomial, and the reason being is because of this negative exponent. You cannot have negative exponents and for it to be a polynomial. This one is a polynomial. And again, you have to look at these variables raised to a 2, which is a whole number. This can be anything. The numerical coefficient can be anything. As long as as long as this here passes the test, we're good. So x to the power of 1, that's a whole number. We're all good. So this is a polynomial. This is not a polynomial, and the reason being is because we have a variable in our denominator. Okay, so as soon as we see a variable in our denominator, we put it to not a polynomial. This is not a polynomial, and again, we look at the variable. We're square rooting the variable, so this makes it not a polynomial. And the rest are. Okay, so that one is, and I'm going to go down here, and this one is. Okay, so again, we look at the variables. This one is a polynomial because it's just a constant term. It's just a number, and a number is considered a polynomial. Here we look at our variables. We look at our exponents. This has an exponent of 1. That has an exponent of 1. That has an exponent of 1. That one does. This one's 2. This one's 1. That one's 1. That one's 1. So they're all whole numbers. We're good. And same thing here. This is 3 times x to the power of 1, so that one's good as well. So those are all polynomials. So on your exam, you will be expected to look at the 4 distractors, or sorry, the 3 distractors and the 1 right answer, and be able to identify what a polynomial is. Okay, so we have different types of polynomials, because remember we had to classify our polynomials. So some polynomials are named by the number of terms they contain. So it's very important to note. Okay, so terms are separated by an addition sign or subtraction signs. Okay, so you just have to look and see if there's an addition sign or a subtraction sign. We know that that separates terms. So if we have a polynomial of 1 term, it's called a monomial. If a polynomial has 2 terms, it's called a binomial, and 3 terms is a trinomial. So the degree of, I don't know what happened there. The degree of the term and then the degree of the polynomial. Okay, well, let's see. I have the term here. I have the definition here. So the degree of the term is the sum of the exponents of the variables of a single term. A variable with no exponent is understood to have an exponent of 1. And the degree of the polynomial is the highest degree of any term in the polynomial. So I just taught you quite a bit here. So I'm sure that the questions that are coming up will practice. So I'm going to go through this really slowly and make sure that you totally understand all the terminology I just gave you. So variables. Your variable or variables, since we only have one letter, it's only x. There's only an x here, so we only have one variable. The number of terms. So here's an addition sign, and here's a subtraction sign. So this is a term, this is a term, and that is a term. So terms are separated by addition and subtraction signs. So there are 3 terms. Because there are 3 terms, it is called a trinomial. Okay, so 3 terms are called trinomials. The numerical coefficient or coefficients. So since we have the number 3 that's multiplied by x squared, our numerical coefficient is 3. And here we have a 2 that's multiplied to the variable. So we actually have 2 numerical coefficients, one for the first term and one for the second term. The constant term is we have to take that subtraction sign and take it with the constant term, because remember in unit, I can't remember which unit that was in. Remember we turn all subtraction signs into addition statements? Okay, so if you remember that, and that's what makes this constant term -1. And remember, the constant term is the term without the variable. Now let's talk degree. So we know that this right here is a term. So what we do is we look at the exponents. So the exponent there is 2. Here, our exponent is 1. And believe it or not, this is actually 1 times x to the power of 0. Now remember, x to the power of 0 is equal to 1. That was one of our laws of exponents that we learned in Unit 2. That is why I can actually, we don't write it in, but it's actually assumed again. So here we have a degree of 0. So once we find the degree, the highest exponent of each of our terms, then what we're going to do is we're going to take the highest one. So the degree of the polynomial is 2. Now I'm sure there was a lot going on there, so I'm going to go through a couple more examples with you. Okay, so let's look at this one. So our variables here are x and y. So those are the 2 letters that are in our polynomial, our algebraic expression. The number of terms, again, is, if I want to, because of the subtraction sign, we can do that already. We can write it as an addition statement, and we can put in all our invisible things Remember our numerical coefficient, if there isn't one, we put a 1 in there, and because we changed this subtraction to an addition statement, that's what makes it -1. So if this helps out to do that, please do. So the number of terms, this is a term right here, and this is a term right here. So we have 2 of them. Because we have 2 terms, it's called a binomial. Okay? Now let's take a look at our numerical coefficients. So this is a term right here. It has variables. So the number that's multiplied to the variables is called the numerical coefficient. So here, this term has a variable. So we take the number that is multiplied to the variable, which is -1. We have no constant term here. Some people would say that the constant term is 0. So if you want to put 0 in there or say no constant term, that's fine. I'd accept either answer. Now let's take the degree. So we look at the terms. This is an exponent of 1 and that's an exponent of 1. So we look at both of these variables together and say that it has a degree of 2 because we have 1 here and 1 here. In this term, we have a degree of 2. So the degree of the polynomial is 2. Okay, so we have to look at each degree, the degree of each term first, just by looking at all of our exponents. And then the degree of the polynomial is the highest number. Okay, so I hope that helped out, but let's do a couple more examples just to make sure. Oh, this one's a tough one. We'll come back to this one. Oh, is that it? Okay, yeah, no, we're going to have to do this. There are no variables. The number of terms is 1. The constant term is 3. Since the number of terms is 1, it makes it a monomial. Monomial. Okay, the numerical coefficients. Well, since we have no variables, there are none. We have a constant term, but we don't have a numerical coefficient. Now this is the tricky part. The degree of the polynomial. We can also write this as 3. If I was to put a variable in there, it would be x to the power of 0. So the degree of the polynomial is 0. Because remember, back in Unit 2, again, I said it once already, x to the power of 0 is equal to 1, and 1 times 3 is equal to 3. And that's how we get the constant term of 3. Okay? So I'm going to stop this video here because I think the next one is modeling polynomials. Okay, and then I'll just break up the lesson into 2. So I'll see you in part 2.